Hi there. In this lecture, we want to practice a complex routing WAN scenario. It's very interesting. Come with me. We have three buildings: headquarters, branch 1, and branch 2. We have different routing protocols inside our building. We have RIP in our headquarters, we have OSPF in branch 1, and we have EIGRP in branch 2. We want to route between these three branches via eBGP or external BGP or their gateway protocol. And we want to redistribute the routes between RIP and BGP, OSPF and BGP, and EIGRP and BGP, and vice versa. And the connections between our branches routers is done via frame relay. It's a very complex scenario that could help you to check your knowledge of Cisco routers and their configurations. All of these routers are IOU devices. I just changed their symbols and changed their host names. Let's do our configurations. Start my configurations from PC1. In PC1, I assign the IP address of 192.168.1.1, the gateway of 192.168.1.254, and 24 subnet masks. In PC2, I assign the IP address of 192.168.3.1, the gateway of 192.168.3.254, and 24 masks. In PC3, the IP address of 192.168.5.1 and the gateway of 192.168.5.254 and 24 masks. We start from our headquarter routers, which is router 1. Interface Ethernet 0/0. Assign the IP address of 192.168.1 and 254 with the subnet mask of 255 and no shutdown. Now PC1 should ping its default gateway. Okay. And interface Ethernet 0/1 IP address 192.168.2.1 255.255.255.0 and no shutdown. And in router 2, configure terminal interface Ethernet 0/1 IP address 192.168.2.1 255.255.255.0 and no shutdown. I do these configurations. I assign the IP address on this interface, I assign the IP address to PC1, and I assign the IP addresses on these two interfaces. Let's check it. Ping 192.168.2.1 duplicate address. Oh, I should put the IP address of 192.168.2.2. Now I should ping the 192, the connection between these. Okay, to save our time, I pause the video and do the same configurations, just the IP addresses, just setting the IP addresses on different interfaces, and I come back after some seconds. Now I assign the related IP addresses to Ethernet configurations, and now I want to do the serial interfaces configurations. All of the interfaces are serial 4/0. I configure the frame relay like this. Let me show you the frame relay configuration. This is frame relay configuration. Port 1 DLCI 101 to port 10 DLCI 202 and port 1 DLCI 102 to 11203 DLCI number. As you could see, this router connects to the port 1, router 4 connects to 10, and router 6 connects to 11. I want to have a PVC between router 2 and router 6 and a PVC between router 2 and router 4. Let's do first our serial configurations. In router 2, I go to interface serial 4/0 first and say encapsulation frame relay and no shutdown. And I go to subinterfaces, interface serial 4/0 point to point, dot 1 point-to-point, assign the IP address of 10.0.0.1 with 255.255.255.0. I assign the related subnet for each PVC and say frame relay interface DLCI 101, and for interface serial /02 point-to-point, I say IP address 10.0.1.1 255.255.255.0 interface serial /0 encapsulation frame relay and no shutdown interface serial /02 point-to-point. I assigned the IP address before, and now frame relay interface DLCI 102. Let's check our configurations. Show running config. Okay, interface serial /0 encapsulation frame relay /0.1 point-to-point 10.0.0.1 interface DLCI. Okay, in router 2 everything seems to be okay. In router 4 I go to interface serial /0 encapsulation frame relay and interface serial /0.1 point-to-point IP address of 10.0.0.2 255.255.255.0 and frame relay interface DLCI 202, and then no shutdown the interface serial /0 no shutdown. Now I should check my VPC status. Let me do it. Show frame relay PVC. I should have an active. That's okay. And I should ping 10.0.0.1, which is router 2. In router 6, also interface serial /0 encapsulation frame relay and no shutdown. Define the subinterface interface serial /0.1 point-to-point IP address of 10.0.1.2 255.255.255.0 and frame relay interface DLCI 203. Now I should have an active PVC here. Show frame relay PVC. You see that I have an active PVC, so I should ping 10.0.1.1, which is router 2. That's okay. So we made the connections between our routers via frame relay. You see that this is connection, this is a PVC between router 2 and router 4, and a PVC between router 2 and router 6, and both are connected. Now I'm going to configure the internal routing. Between router 1 and router 2, as I told you before, between router 1 and router 2 we have RIP. So we configure these two routers. Configure terminal router RIP network 192.168.1.0 and 2.0. That's okay. And in router 2, configure terminal router RIP network 192.168.2.0. Now I expect router 2 learn network of 192.168.1.0 from RIP. As you could see, this is okay, and router 2 learns from router 1 how to reach the network of 192.168.1.0. Now I go to router 4 for configuring. Router 3 and router 4 are configured via OSPF. So I go to router 3, configure terminal router OSPF 1 network 192.168.3.0 with this wildcard mask in area 0, and also network of 192.168.4.0, and in router 4 also I should configure OSPF, configure terminal, router OSPF 1, network 192.168.4.0 with this wildcard mask in area 0. You know that they must be in the same area to become neighbor. This is OSPF neighborship conditions. It took some seconds to 2 OSPF routers become neighbors. If we issue show IP OSPF neighbors, you will see that they are now in full, and router 4 should learn about router 192.168.3.0 from OSPF, and you see that that's okay, and these two routers are neighbors and they teach each other what they learn. In router 5 we have to configure EIGRP, so I go to global configuration mode and assign router EIGRP1. First I issue the command no auto summary, and then command network 192.168.5.0 with this wildcard mask, and network 6. Also in router 6, router EIGRP1 and network 192.168.6.0 with this wildcard mask. Now these two routers must become neighbors. That's okay. And router 6 should learn about the network of 5.0 from EIGRP. As you could see, that's okay. So we do our internal configurations. We do OSPF here, EIGRP here, and RIP here. Now it's the time to configure BGP between our 3 routers. Router 2 has the AS number 100. This router 4 has AS number 200, and router 6 has 300. So we go to router 2 and say router BGP 100 and say neighbor 10.0.0.2, and the remote AS is 200, and neighbor 10.0.1.2 and the remote AS is 300. I want to neighbor router 2 with router 4 and router 6. Now I go to router 4 and say router BGP 200 neighbor 10.0.0.1 and the remote AS is 200. Now these two routers must become neighbors. We have some errors apparently. Wrong AS. Why? 200. Oh, sorry. The remote AS is 100. Configure terminal router BGP 200. Sorry. Let me correct my mistake. Neighbor 10.0.0.1. Remote AS is 100. Now these two routers are become neighbors. And also in router 6, configure terminal router BGP 300 and neighbor 10.0.1.1 and the remote AS is 100. I don't repeat my mistake. Now these 3 routers are become neighbors, but if in router 6 I issue the command show IP route, you will see that just the networks that are directly connected and via EIGRP is present in its routing table. Now we want to redistribute the internal routes from RIP, from OSPF and from EIGRP into BGP and vice versa. So we go to router 2 and in router BGP 100 we issue redistribute RIP. In router 4, in router BGP 200 we redistribute OSPF, the process ID 1, and in router 6 we issue the command router BGP 300 and redistribute EIGRP AS number 1. Now I expect router 2 to learn the network behind the others. And if I issue show IP route BGP, you will see that router 2 learns about network 3.0 and 4.0. Router 4 show IP route BGP about 1, 2, 5, and 6. And router 6 show IP route BGP 1, 2, 3, 4. Router 2 also must learn other things. Yes, everything is okay now. These 4 routers knows about all networks. If I issue show IP route command, you will see that show IP route commands, you will see that our borders routers knows about the network 1.0, 2.0, 3.0, 4.0, 5.0, and 6.0. But our scenario is not complete yet. Our PCs should ping each other, but routers behind these routers does not know about the other areas, the other routing protocols IP addresses. I mean, router 1 does not know about the networks of 4 and 3 and 5 and 6 networks. Let's check it. In router 1, if I issue the command show IP route, you will see that only knows about network 1 and 2, which are directly connected to it. So we have to redistribute BGP routes to RIP, to OSPF, and to EIGRP. So I go to router 2 and go to router RIP. I want to ask RIP to advertise the BGP route to RIP. But there's a trick. In RIP and in EIGRP, you have to assign the metrics to BGP to RIP could advertise the BGP routes. So when I issue the redistribute BGP, I assign the metric, for example, metric BGP 100 in router 2, and assign the metric of, for example, 1 to this. Now I expect router 1 to learn other networks. Show IP route. You will see that network router 1. Let me clear the screen. You will see that router 1 knows about 1.0, 2.0, 3, 4, 5, and 6. We have to do the same configurations in router 4 and router 6. In router 4, which is in OSPF area, you don't need to assign the metrics. Just go to router OSPF 1 and issue redistribute BGP 200. And in router 3, now I expect some new routes. Show IP route. You will see that the other networks come to the routing table with E2, external type 2 in OSPF. In router 6, we have to redistribute BGP to EIGRP, configure terminal, router EIGRP 1, redistribute BGP. These values are Cisco recommended. These are the K values: 100, 1, BGP 300, first metric, then the value of kilobits per second, for example 100, and microseconds 1, 255, again 1, and finally 1500. These are the Cisco recommended value for fast Ethernet. I use them in Ethernet too. If you want to dig deeper in these values, you could refer to Cisco's website and choose the best metrics for your network. Now I issue the redistribute command and expect to have the other routes in router 5. If I issue show IP route, you will see that external route from EIGRP is learned in the routing table. So PC1 now should ping 192.168.3.1, which is PC2 IP address, and 5.1, which is PC3's IP address. Okay, let's wrap up. In this lecture, we've learned many things. We configured RIP for internal routing, we configure OSPF for internal routing, and we configure EIGRP for internal routing. We configure external BGPs inside a frame relay network between 3 routers. We distribute RIP routes to BGP, OSPF to BGP, EIGRP to BGP, and vice versa with the related commands. I hope this lecture helps you to improve your knowledge, and see you in the next lecture.